For the next 3 weeks, we are going to work on trigonometry, and to start this new topic, we are going to review angles. Now, angles are often illustrated with two rays starting from the same initial point. Often that initial point will be the origin, but it doesn't have to be. So I could have a ray that two rays that start at B. Maybe A is on the first ray and C is a point on the second ray, and I'd be allowed to talk about the angle ABC. So following, so ABC will give me this angle here. So imagine that this angle is, I don't know, 30 degrees. We would say that the angle ABC is 30 degrees. We'd call that side the initial side. Now, often this will be the x-axis. So we're going to position our angles in the plane. B is often going to be the origin. So we're often going to actually reuse O for that point. And this side here, where it ends, is the terminal side. So maybe we should maybe put a little arrow here saying we go from the initial to the terminal side. Now, already with this little notation, I've added this arrow. So there's some sort of indication that this angle is conveying the idea of a rotation. And this is what we'd like to our angles to sort of illustrate like that. I would like them to represent not only like a measurement but also some sort of direction. So we would like them to be oriented and to convey the idea of a rotation. So we'll actually use the following convention. It's just a convention. We've decided, and most textbooks follow that convention. I would say all textbooks. So if I have a clockwise rotation, okay, that will be equivalent to a negative angle. Okay, and counterclockwise rotation will be a positive angle. So allowing ourselves to write, you know, plus or minus 30 degrees allow us to decide in which direction that rotation is being performed. So very often, like I said, we're going to start. So our initial side will be the x-axis, and we're going to be starting. We'll be turning one way or the other, either clockwise or counterclockwise, starting from the x-axis. So if I go this way along the x-axis, I've moved counterclockwise. So I move from the x-axis towards the positive side of the y-axis. So we could say this is 30 degrees. If instead my rotation is not this way, but the other way around, like that. So now I've moved clockwise, so it's going to be a negative angle. And let's say this is this is here inside 30 degrees. A full rotation is 360, so that makes this angle 330 minus 330 degrees. Okay, I could keep on going like this. I could also move. Okay, let's say again this is 30, but this is not the angle I want to do. I want to actually rotate a full rotation and then 30 degrees more. So this is an angle of 390 degrees. Okay, so we would say that these two angles here are coterminal. These two angles are coterminal. They end up at the same place while starting at the same place along the x-axis. Now we're going to use variables to indicate our angles, and often for those variables we use Greek letters. So angles are often, they don't have to be, but often indicated using Greek letters. So I'll show you the most often used letter is the letter theta. Okay, it's like a circle and you put a straight bar into it like that. Then there's phi. Phi you do it like that. So I'll do it again, like this. This is phi. There's alpha. Alpha is actually pretty much used for angles. There's also beta. It's like a B. This is the ancestor really of the letter B. Beta. This alpha is the ancestor of A. Right? A is almost like an alpha. Beta, and finally gamma. Like that. So we might illustrate like a generic angle like so. Theta, just like that. Okay. Now these angles, okay, their terminal side can be found in either one of the four quadrants. The quadrants are the four areas of the planes that are split by the x and y axes. So this is the first, second. Notice that we're the one there's one and then two goes well, you go from 1 to 2 by going around counterclockwise. Okay, so 1, 2, 3 is here, and we often indicate them with Roman numbers. Okay. And that's pretty much it for just basic stuff, terminology. So obviously for coterminal angles, you can find a coterminal angle to a given angle by adding or subtracting 360 degrees, right? If you've got an angle like this, okay, if I add 360 to it, I get another coterminal angle. But if I subtract 360 to it, let me do a good job here. So if I subtract 360 from that one, I'm going to get this other coterminal angle, and I could subtract it 2 times 360, okay, and keep rotating like that. So for example, if this one is 30 degrees, okay, if I do 30 degrees minus 360 degrees, okay, I'm going to get minus 330 degrees. So I'm going to get this angle here, okay, minus 330. And if I keep just subtracting another 360, I'm going to get another coterminal angle. So I could keep on subtracting 360 degree. This would be minus 960, and that would be also coterminal, and so on. Or I could add 2 times 360, and that would still be coterminal. So as long as you add or subtract multiples of 360, you're going to end up with coterminal angles.